Welcome to our exploration of the power of inductivity. Today, we'll dive into what inductivity means, why it matters, and how it shapes the world around us. Inductivity, often called inductance, is a fundamental property in physics and engineering, especially in the field of electromagnetism. It's the ability of a conductor to store energy in a magnetic field when electrical current flows through it. This concept might sound technical, but it's at the heart of many devices and systems we use every day. Let's start by understanding the basics before moving into real-world applications and fascinating examples. Ductivity or inductance is a property of an electrical circuit that opposes changes in current. When current flows through a coil or wire, it creates a magnetic field. If the current changes, the magnetic field changes too, which in turn induces a voltage that resists the change in current. This is the essence of inductivity. It's measured in units called henries. Inductivity is crucial in designing circuits, especially those that need to manage or filter signal. Understanding this property helps engineers create more efficient and reliable electronic devices. Coils, also known as inductors, are the most common components used to harness inductivity. When you see a tightly wound wire in an electronic device, you're likely looking at an inductor. These coils store energy in their magnetic fields and release it when needed. Inductors are essential in power supplies, radios, and many other electronic systems. They help smooth out electrical signals, filter noise, and even store energy temporarily. The design and size of the coil determine how much inductivity it provides, making them versatile tools in engineering. Whenever current flows through a wire, a magnetic field forms around it. This invisible force is what gives inductivity its power. The stronger the current or the more loops in the coil, the stronger the magnetic field becomes. These magnetic fields can interact with other components, influence nearby circuits, and even induce currents in other wires. This phenomenon is used in transformers, wireless charging, and many other technologies. Understanding how magnetic fields work is key to unlocking the full potential of inductivity. You might not realize it, but inductivity plays a role in many everyday devices. From the charger for your phone to the speakers in your car, inductors are working behind the scenes. They help regulate power, filter out unwanted noise, and ensure devices operate smoothly. Even the ignition system in your car relies on inductivity to generate the high voltage needed to start the engine. By understanding inductivity, we gain a deeper appreciation for the technology that powers our daily lives. Transformers are a perfect example of inductivity at work. They use coils to transfer energy between circuits through magnetic fields, allowing electricity to be transmitted over long distances efficiently. Without inductivity, our power grids wouldn't be able to deliver electricity from power plants to homes and businesses. Transformers step up the voltage for transmission and step it down for safe use, all thanks to the principles of inductivity. This technology is a backbone of modern civilization. Wireless charging is a modern marvel made possible by inductivity. When you place your phone on a wireless charger, coils in both the charger and the phone create magnetic fields. These fields transfer energy without any physical connection. Inductive charging is not only convenient but also safe and efficient. This technology is expanding into electric vehicles and other devices, showing just how powerful and versatile inductivity can be in our daily lives. Inductivity is crucial in radio and communication technology. Coils and inductors are used in tuning circuits to select specific frequencies, allowing radios to pick up different stations. Without inductivity, we wouldn't have the ability to filter and amplify signals for clear communication. This principle is also used in televisions, cell phones, and many other communication devices, making inductivity a key player in keeping us connected. Audio systems rely on inductivity to deliver high-quality sound. Inductors are used in speakers and crossovers to filter frequencies, ensuring that each speaker receives the right range of sounds. This results in clearer, more accurate audio. Whether you're listening to music at home or in your car, inductivity is working behind the scenes to enhance your listening experience. It's another example of how this property shapes the technology we enjoy every day. Power supplies use inductors to regulate voltage and current, providing stable power to electronic devices. Inductivity helps smooth out fluctuations and prevent damage to sensitive components. This is especially important in computers, smartphones, and other devices that require precise power management. By controlling the flow of energy, inductivity ensures that our gadgets run reliably and efficiently. Electric motors are another area where inductivity shines. Motors use coils to create rotating magnetic fields, which turn electrical energy into mechanical motion. This principle powers everything from household appliances to electric vehicles. Inductivity allows motors to operate smoothly and efficiently, making them essential in modern technology. The next time you use a fan or a blender, remember that inductivity is making it all possible. Many sensors rely on inductivity to detect changes in their environment. For example, metal detectors use coils to sense the presence of metal objects by detecting changes in inductance. Other sensors use similar principles to measure position, speed, or proximity. Inductivity-based sensors are widely used in industrial automation, security systems, and even in smartphones. Their reliability and precision make them invaluable in countless applications. Medical technology also benefits from inductivity. Devices like MRI machines use powerful magnetic fields generated by coils to create detailed images of the body. Inductive sensors are used in various diagnostic and monitoring equipment, providing accurate and non-invasive measurements. The ability to harness inductivity has revolutionized healthcare, enabling safer and more effective treatments. Renewable energy systems, such as wind and solar power, use inductivity to manage and convert energy. Transformers and inverters rely on inductors to handle the flow of electricity from renewable sources. This ensures that energy is delivered efficiently and safely to the grid. As we move toward a more sustainable future, inductivity will play an even greater role in powering our world with clean energy. Modern transportation systems, from electric trains to hybrid cars, depend on inductivity. Electric motors, charging systems, and even some braking systems use inductors to control and manage power. Inductive charging is being developed for buses and trains, allowing them to recharge wirelessly at stops. This technology is making transportation cleaner, more efficient, and more convenient for everyone. Factories and industrial plants use inductivity and automation systems to control machinery and processes. Inductive sensors detect the position of moving parts, while inductors and power supplies and drives ensure smooth operation. This technology increases efficiency, reduces downtime, and improves safety in industrial environments. Inductivity is a key enabler of the smart factories of the future. Modern lighting systems, especially fluorescent and LED lights, use inductors to regulate current and prevent flickering. Inductivity helps ensure that lights operate efficiently and last longer. This not only saves energy but also reduces maintenance costs. The next time you flip a light switch, remember that inductivity is helping to brighten your world. Computers and servers rely on inductivity for stable power delivery and signal processing. Inductors are used in motherboards, power supplies, and network equipment to filter noise and maintain reliable operation. As computing power increases, the role of inductivity becomes even more critical in managing complex electronic systems. Robots use inductivity in their motors, sensors, and power systems. Inductive components help robots move precisely, sense their environment, and operate safely. As robotics technology advances, inductivity will continue to play a vital role in enabling smarter, more capable machines. Aerospace technology depends on inductivity for navigation, communication, and power management. Inductors are used in avionics, satellite systems, and propulsion controls. Their reliability and efficiency are critical in the demanding environments of flight and space exploration. From smartphones to smartwatches, inductivity is a key part of consumer electronics. Inductors help manage power, filter signals, and enable wireless charging. As devices become smaller and more powerful, the importance of efficient inductivity solutions continues to grow. Home appliances like washing machines, refrigerators, and microwaves use inductors to control motors and manage power. Inductivity ensures these devices run efficiently and safely, providing convenience and comfort in our daily routines. Electric vehicles, EVs, rely on inductivity for motor control, battery charging, and power management. Inductive charging stations are making it easier to recharge EVs without cables. Inductivity is helping drive the transition to cleaner, more sustainable transportation. Storing renewable energy efficiently is a major challenge, and inductivity plays a role here too. Inductors are used in battery management systems and energy storage devices to regulate charging and discharging. This helps maximize the lifespan and performance of batteries used in solar and wind power systems. Smart grids use inductivity to manage the flow of electricity, balance supply and demand, and integrate renewable sources. Inductive components help ensure reliable and efficient operation, making our power infrastructure smarter and more resilient. Signal processing relies on inductivity to filter, amplify, and shape electrical signals. Inductors are used in audio equipment, communication systems, and data networks to ensure clear and accurate transmission. This technology is essential for everything from music production to internet connectivity. Scientists and engineers use inductivity in research labs to develop new technologies and materials. From experimental circuits to advanced sensors, inductivity is a tool for innovation and discovery. Its versatility makes it a cornerstone of scientific progress. Inductivity is a key topic in science and engineering education. Students learn about its principles through hands-on experiments and projects. Understanding inductivity helps build a strong foundation for future engineers and inventors, inspiring the next generation of innovators. Artists and designers are finding creative uses for inductivity in interactive installations and kinetic sculptures. By integrating coils and magnetic fields, they bring movement and interactivity to their works. This fusion of art and technology showcases the versatility and beauty of inductivity. Security systems use inductivity in sensors and alarms to detect unauthorized access or movement. Inductive loops are often embedded in doorways or floors to sense when someone enters or exits. This technology helps keep homes and businesses safe and secure. Contactless payment systems use inductivity to transfer data and power between cards and readers. This technology enables fast, secure transactions without physical contact, making payments more convenient and hygienic. Smart home devices use inductivity for wireless charging, power management, and communication. Inductive sensors help automate lighting, heating, and security, making homes more comfortable and efficient. Wearable devices like fitness trackers and smartwatches use inductivity for charging and data transfer. This allows for sleek, waterproof designs and convenient use. Inductivity is helping make wearable technology more practical and user-friendly. Gaming consoles and accessories use inductivity for power management and wireless connectivity. Inductive charging keeps controllers ready to use, while inductors help ensure smooth, lag-free gameplay. This technology enhances the gaming experience for players everywhere. Smart lighting systems use inductivity to enable wireless dimming and color control. Inductive sensors detect presence and adjust lighting automatically, creating energy-efficient and responsive environments. Modern agriculture uses inductivity in automated irrigation systems, soil sensors, and machinery. Inductive sensors help monitor soil moisture and control equipment, improving crop yields and resource efficiency. Environmental monitoring systems use inductivity in sensors to track air and water quality, weather, and pollution. These systems provide real-time data to help protect our planet and respond to environmental challenges. Logistics and supply chain systems use inductivity in tracking devices and automated warehouses. Inductive sensors help monitor inventory, track shipments, and streamline operations for greater efficiency. Manufacturing processes use inductivity in machinery control, quality assurance, and automation. Inductive sensors detect defects, monitor production lines, and ensure products meet high standards. Construction equipment uses inductivity in sensors and control systems to improve safety and efficiency. Inductive sensors help monitor equipment status and detect hazards, supporting safer worksites. Marine technology uses inductivity in navigation, communication, and power systems on ships and submarines. Inductive sensors help ensure safe and efficient operation in challenging ocean environments. Spacecraft and satellites use inductivity in power systems, communication, and scientific instruments. Inductive components must withstand extreme conditions, making reliability and efficiency crucial for successful missions. Emergency systems use inductivity in backup power supplies, alarms, and communication devices. Inductive components ensure these systems remain operational during power outages or crises, providing vital support when it's needed most. Future of Inductivity is bright, with ongoing research leading to new materials, designs, and applications. From quantum computing to advanced medical devices, inductivity will continue to shape the technologies of tomorrow. As we unlock new possibilities, the power of inductivity will remain a driving force in innovation. Conclusion: inductivity is a powerful and versatile property that underpins much of modern technology. From powering our homes to advancing healthcare and enabling new forms of communication, its impact is everywhere. By understanding and embracing the power of inductivity, we can continue to innovate and build a brighter, more connected future.